Alright, so you guys are probably wondering what's the difference between these normal curves and standard normal curves and which ones you use at which times. Well, let's just say that these four curves are normal curves. And you know that because they all look really different and they have like these different colors and different shapes and they're just all really distracting and hard to read. But our goal is to make these confusing normal curves look like standard normal curves. See how pretty and beautiful that is? It's just so nice to look at. And how do we know this is a standard normal curve? Because the mean is centered around 0 and the standard deviation is 1. And you know that's the standard deviation because it is right below the inflection point on both sides of the graph. We want to make all these normal curves look like standard normal curves, not only because they look so pretty, but because it'll be easier to compare and analyze later. So how do we do this? We use z-scores. Cool animation, right? Okay, now let's just look at the equation for how to calculate a z-score. The equation is z equals x minus mu divided by sigma. So what are all these variables? X is basically the raw data value, which you can find from any normal distribution. It doesn't matter what it is, it's your choice. And mu is the mean of the distribution. It's where the distribution is centered. And sigma stands for the standard deviation. So now let's look at two curves. The top curve is a normal curve with normal values, and the bottom one is a standard normal curve. And I'm going to show you how I convert that normal curve into the standard normal curve at the bottom. So looking at the normal curve, you can see that the mean is 60. Okay, so let's use that as a data value. So x equals 60, and then mu equals 60. So 60 minus 60 is 0. And it doesn't matter what the standard deviation is, so that's 0. And that's how the mean turns into 0 for the standard deviation, or the standard normal curve graph. So the standard deviation for our normal curve is clearly 30 because 60 minus 30 is 30 and 90 minus 60 is 30. So let's just choose another point. Let's choose 90. 90 will be our x. And our mu is still 60, so 90 minus 60 is 30. And since our standard deviation is also 30, we divide that by 30 and we get 1. So where the 90 is, we can see on the standard normal curve, it's now 1. So the reason why it's so convenient to convert numbers from a normal curve to standard normal curve numbers is because everything is now in terms of its standard deviation. So you can see that the first curve, the normal curve, has a standard deviation of 30, but since we divide by 30, its standard deviation is now 1. And that is true for every normal curve, no matter what standard deviation. Every standard deviation for a standard normal curve will be 1.